To find the absolute maximum and absolute minimum of the function f of xy given as xy minus 5y minus 25x plus 125 on a given domain of all the points on or above the curve y equals x squared and on or below the line y equals 28. First, we'll try to plot the domain of this function. Let us draw the domain for y equals x squared and y equals 28. So I will take the calculator. In the calculator, we type y equals x squared and y equals 28, and then graph your function with standard window, and then see how does it look. So the graph is like this. Okay, so we'll plot this one here. That's the graph. And now we need to find the intersection points between y equals x squared and y equals 28. The intersection, what happens, you can write x squared is 28. So you get x equals plus or minus square root of 28. So then we list the points now. Points we have x equals negative square root of 28. In that case, y is 28. Or you can just square it because y equals x squared. The other right hand side point is the square root of 28 and y equals 28. All right. So next, we can see what happens to my domain now. We can see my x is in this case between negative square root of 28 to square root of 28, and y value you can see from the graph goes from 0 to 28. The boundary points are inclusive. Okay, our next step will be to find the critical point from the function we have f of xy equals xy minus 5y minus 25x plus 125. Now, how do you find this critical point? So we need to take the partial derivative of the function with respect to x, so that we will get y minus 25 and set equal to 0. Then you can say y equals 25, and partial derivative with respect to y gives me now x minus 5. When you set equal to 0, you get x equals 5. So now we can list this point also here, that we are saying the critical point we have found is 5, 25, which is inside the domain. All right. So next, we need to investigate what happens to the surface when you move along the line y equals x squared. So what we will be doing, we just replace y by x squared in our main function. Then you get this one, and since this is a function of one variable only here, x, we call it gx. Now from this gx, we want to see if I have any critical point. So take the derivative again. So you got 3x squared minus 10x minus 25, and set this equal to 0. So we need to solve that one now. So we have 3x squared minus 10x minus 25. If you say equal to 0, then you get x equals minus b, so it is plus 10 here, plus or minus square root of 10 squared will give you 100, minus 4 times a is 3 and c is negative 25, all over 2 times a is 3. Now if you simplify further, you can see 10 plus or minus, inside we are getting 400 over 6. So this is basically 10 plus or minus 20 over 6. Now if you find two values here, 10 plus 20 over 6, that gives you 5. And then 10 minus 20, which is negative 10. So negative 10 over 6 is negative. And that is simplified version will be 5 over 3, right? So this point also we can list here. We are getting, solving this quadratic equation, x equals 5 and negative 5 over 3, as you see there. on the right hand side. So the points are now when x is 5, y is 25 because this is squared. And another portion is negative 5 over 3 square will be 25 over 9. So we got all these critical points. We need to list all the points we have. Now we need to evaluate our function at the points that we have listed in the first column on the table. So the first point we have negative square root of 28, comma 28. So replace your x by negative square root of 28 and y by 28 and simplify. Your result will come out as negative 30.8745. The next point we are taking 5, comma 25. After simplification we get 0. Then we are taking third point, it's negative 5 over 3 and 25 over 9. So that gives me 148.1481. Next, we take the fourth point, square root of 28 and 28. That gives me 0.8745. Now from there you can see the smallest is negative 30.8745 and the largest is 148.1481. So we got our absolute minimum and absolute maximum, and also related points are on the left column of this table. And we are done. Thank you.